So we integrate between whatever two numbers it is. I'm just going to write A and B, whatever the two things are, and we do pi y squared with respect to x. Now, this is the important bit, the squared bit. The pi bit, remember how I told you to ignore a particular method that they were teaching you around taking out fractions at the start? Well, that's what we're going to do today. We're going to ignore the pi and just shove it back in at the end because it makes our lives easier. It doesn't have a constant attached to it. Sorry, it doesn't have a variable attached to it. So we can just sort of ignore it and then do all our stuff and then put it in at the end. So it's really not that hard. But let me show you what I mean. So let's do an example. All right, so this is the general equation, all right? So if I do, I'm going to have my equation as y equals 9 over 3x plus 2. And I would like to integrate this between 2 and 1. I really should not have drawn it over there because now I have no space. I want to integrate, let's get rid of the y. I want to integrate this between 2 and 1 with respect to x. Now, it is really important that you read the questions carefully because they will tell you whether you're rotating around the x or the y axis. If you're rotating around the x-axis like normal, we don't have to think about it, right? We just do what we normally do. But I will do an example where we rotate around the y-axis and I'll show you what to do. It's easier than it sounds. But to begin with, just make sure you know whether you're rotating around X or Y. Okay, people on laptops, can we shut our screens and just watch this for now, please? What should the first thing I do be?
Integrate.
No.
Square.
No. What? Rewrite it. Okay, so how am I going to rewrite this?
X plus 2 to the power negative minus 1.
Okay, cool. All right, so that is the first thing I am going to do. Okay, actually, it's not the first thing I'm going to do. I am stupid. Josh was right. All right, so what I'm going to do is I'm going to take this. So I want you to think about this as an equation. Y equals 9 over 3x plus 2. I have been told that I need to do pi times y squared. This is y.
Square.
So I just have to square it. So what I'm going to do is I'm going to shove the pi out the front because I don't want to do anything with it. Pi annoys me. So I am going to do 9 over 3x plus 2, and I am going to square all of that, and it's still with respect to x. We haven't done any integration or anything yet, okay? So stick the pi out the front. We'll deal with it at the end. Then I need to do this part of my equation. So when you're squaring something, what do?
Everything.
Yeah, you just square top and bottom, right? So I've still got my pi out the front. I haven't integrated yet, so I need to keep that there. So what have I got on my top? 81, and then I've got 3x plus 2 squared. Do not tell me it's 9x squared plus 4. I will paper cut you with your own work, right? We can't just square first and last terms. You square the whole thing. Now I'm going to rewrite it. Okay, we're doing it with respect to x. So now I'm going to rewrite this whole thing. I'm going to integrate it between 2 and 1. 81 times 3x plus 2 to the power of negative 2 with respect to x. Now I can do some integrating, right? Now I've got it in a form that I can do something with it. So I'm still going to leave my pi out the front. So I've got this pi that I haven't dealt with yet. So what happens here? How do I integrate this?
Add 1 to v.
Okay, add 1 to the power. Let's do that first. So I've got negative 1. Now what? What? Oh, thank you. Yep. Divide by negative 1. Is that it? Why is it times 3? Chain rule. Good. So we're also dividing by the derivative of the brackets. All right. So I know it's with between 2 and 1. So I've got my integrated thing. Let's simplify all this out. So let me just write that a bit bigger. I didn't write it big enough. All right, so I'm still going to leave the pi out the front. That does not look like a pi. All right, so do we know what 81 divided by negative 3 is? Negative 27. 3x plus 1. Actually, let's not write it like that. If I have a negative 1, what does it mean? Okay, so it means it belongs on the bottom of the fraction. So this is over 3x plus 2, and I'm integrating between 2 and 1. So what do I do next?
3 times.
Yeah, I'm going to put the 2 in there. So I've still got my pi, and I'm going to do negative 27 over 3 times 2 plus 2 minus, I should put brackets around this whole thing, negative 27 over 3 times 1 plus 2. Gosh, I'm needing a lot of space. So I've got a pi, and then if I simplify this, I get negative 27 over 8. And then if I simplify this, I get negative 27 over 5. Oh, why am I using the wrong brackets? All right, and then if you put all that together, you end up with 81 over 40, but I've still got this pi. So all I do is put the pi on there. So now I get 81 pi over 40 units squared. Cubed. We're doing 3D space this time. Yeah. Okay, so you can see it is essentially the same thing that we've been doing, but there is an extra step with a pi out the front and you have to square y. Let's do another example of this. All right, I am going to say, okay, this time what I'm going to do is I'm going to have some empty space that I also have to deal with. So I'm going to say that y equals x squared, okay? So that's fine. Oh, no, actually, I don't want to do that yet. That's the y one. I'll do that later. All right, I'm going to say 2x squared plus y squared equals 9. So this is going to look like that. Okay, and I want to integrate between these 2 points. This point is 2, 1, and I want to find this space as I rotate it around the x-axis still, right? The question will tell you which axis to use. So if I rotate this around the x-axis, what is the problem you can see? I'm going to have this gap, right? So if I rotate this shape around the x-axis, I don't want this space in here. What shape is this going to be? It's a cylinder. If you turn it around, it is so. This empty space. No, but I'm going between 2 and 1. Sorry, I'm going between 2, yeah. So I need to subtract. Oh, that's not a good color. I need to subtract this bit in here. That will be a cylinder, right? Because I've got my perimeters between 0 and 2. What? Yes. It won't because I'm stopping before I get to the end, right? I've got this point. That means I go straight down. Okay, so if I'm doing pi between 2 and 1, and this is going to be y squared with respect to x. So what do I need to do? What's the problem with what I was given? It's not arranged properly, so I need to rearrange this to get y by itself, right? So then I have y squared, yeah.
You just leave the y squared.
Yeah, exactly. So I've got 9 minus 2x squared. I don't need to square y. Y is squared. So that's really nice for us. So what we're going to do is we're going to integrate between 2 and 1 with 9 minus 2x squared with respect to x. And we don't need to square this like we did before because y is already squared. Okay? All right, so now we need to do what we normally do. But I also need to subtract, right? So let's worry about that at the end. We're going to subtract the cylinder. It's not that bad. Okay, so what do I do first? I need to integrate first. So what do I do? What? Huh? 9x? How? Okay, so, sorry, say that again. Yeah. Okay, so I'm adding a power to this one. I'm also adding a power to this one and then dividing by the new power. I mean, you can divide by the new power there. What?
2/3 outside and x cubed. No, well, same thing.
How does it make a difference? It's the same thing.
No, this is the.
You don't look good. All right. All right. Okay. You know, I didn't know that. Okay. I'm not very good at censoring my own sarcasm. Okay, so let's put in our numbers. We've got 9 and 2. Shh. Okay, I don't need why am I putting 1? That's irrelevant. Okay, so 9 times 2 minus 2, 2 cubed over 3. And then I need to subtract 9 times 1 minus 2 times 1 cubed over 3. And then, okay, so then I have my pi outside still. This is going to be 18 minus 16 thirds. 18 minus 16 thirds minus, and this is 9 minus 2 thirds. Still minusing the cylinder. Okay, so if I get that, okay, okay, let's go back up here and see if we can figure it out. So the cylinder is what? How do you work out a cylinder? Yeah, pi r squared h. So what is r?
2, 1, 2, 1.
The cylinder is going to be this, right? So this is the cylinder. Is it?
No.
No, it's not. What is it? It's not half that.
No, it's what?
Why is it 1? It is 1. Right, because this is half of it, because it goes down here as well, remember? Right, we've got this bit that we're taking away too. So this, yeah, it is 1. All right, so this is going to be pi 1 squared. And what's the height of the shape? Right, times 2. So isn't it just 2 pi?
What?
It's 2 pi.
No.
Because it's pi times 1 squared times 2, which is 2 pi. Yes. Wait. Because I was just trying to show you that that's the second half of the cylinder. Right? Yeah, because it's a 3D shape. So then we end up with 32 pi over 3 units cubed. That is our final answer if we put all this together. If you type all that into a calculator, you get 32. Right? This bit here is 32. Well, 32 pi over 3 if you put the whole thing together. Okay.